Hey guys, it's the Teaching Tube, and now we're going to do some limits. Um, but let's kind of go through this in a graphical manner and think about exactly what a limit means, okay? So before we go through any notation, we'll just look at some functions, okay? So this is a function of x, okay? And so we go along this function, oh, forgot the arrows. And this function is a straight line until we make it to here, and then it has a value of something at this point, and it keeps going, okay? But it goes down to a different level. So what a limit is it tells you what your function is tending towards at a specific point. Not a function's value, but what it's tending towards, okay? And there's a left limit and a right limit, or a negative side limit and a positive side limit, okay? So the limit from the negative side is if we get really close to the negative side and we start walking along this line, then the limit of f of x evaluated at 1 on the negative side would be the value that we would get to if we could stand on as close to 1 as possible following the function there. And so obviously the limit of f of x at 1 from the negative side is not this value. This is the actual value of f of x. But what the limit tells us is if we walk along this line, then we're going to get to this value right here from the negative side. So I'll just put a little negative here.
Negative limit.
Yes. So the limit from the positive side is the same thing. So we just walk along the positive side until we get to a place, and that's this thing, and that's the positive limit. And so what we can see is that neither the positive or negative limit have to be the value of f of x there. Sometimes they could be, but they don't have to be. And so there's also one other thing that's important. It's that, look, the positive and negative side are different. And so that's when we say a limit doesn't exist for both the positive and the negative side. And when we want to take a limit of exactly 1 point from both the positive and the negative side, or from every direction, then we don't put a positive or a negative in the limit notation. So I'll go over that after we do another graphical example. Okay. So this is an example of a limit that does exist, okay? Meaning it does exist from every direction that you approach it, and it's the same value every place that you approach it, okay? So again, this is not the value of the limit, okay? This is the value of the function, not the value of the limit. So we want to walk along the left side, the negative side, and take the limit from the negative side of g of x at 1. And we get this value, okay? Now let's do it from the positive side. And we get this value. So that means, exactly, again. So if we get the same value of the limit for the positive and the negative side, then we say the limit exists.
The limit exists.
Yes, thank you.
I wanted to jump the gun.
Yeah, I know. And so if the limit exists, then we can give a value for that limit, no matter which side we come from, okay? And so how we write that is this. The limit of f of x, or g of x in this case, as x approaches a number, which in this case is a 1, is equal to...
Does not exist. Does not exist. For f of x.
Yeah, so let's go back to f of x. Well, why don't we first do the positive and negative sides? Okay, so positive and negative of f of x. Okay, so now I get to assign some values to these things. So why don't we give it 1, 2, and 3, okay? So if we look, 3 is never the right answer, okay? Because there's nothing telling us that we would ever get there. This is just a shot in the dark, okay? But we can see for sure that as we go from the positive side, we get 1. And as we go from the negative side, we get 2.
2! I knew that one.
And so, since these two are not equal,
Doesn't exist.
yes, the limit of x approaches 1 of the whole function does not exist.
DNE.
Well, one time in my math class, everyone wrote DNE for does not exist, and my professor was wondering why everyone wrote 1 on their paper, because obviously it was wrong. Yeah. And then they realized. Okay, anyways, now let's do the same thing. Yeah, seriously. Now let's do the same thing for g of x. So, let's assign a value. And this is 2. Remember, this thing is not right. It's completely wrong, okay? And so, we're never going to get 2. But we can see that as we walk from the positive side, that's what this plus means, that, okay, we get 1. And so, let's do the same thing for the negative side.
Do we get 1 again?
Well, let's walk along this curve. Oh, we get 1.
Yes, I was right.
And so, what we get is, since they are equal, then they equal the limit of the entire function, and that's when there's no script on this thing, and that would be equal to 1.